Assalamualaikum warahmatullahi wabarakatuh and welcome everyone. So let us start our webinar by reciting Surah Al-Fatihah. Thank you for joining us for today's webinar. So I am Dr. Syahada Atika Idris Aidi and I'll be your host for today. So today we are presenting problem solving using TRIZ, the theory of inventive problem solving, presented by professional technologist Dr. Zulhasni bin Abdul Rahim. For your information, our webinar today consists of two parts, where we will have the first part of presentation by Dr. Zulhasni for about 45 minutes to 1 hour, and then we will have a 5-minute break. After that, we'll continue again the talk followed by the Q&A session at the end of the talk. Just a little housekeeping before we get started. If you have any question during the presentation, please type them into the question box. I'll bring them up at the end of the session. So first of all, may I briefly introduce to you our guest speaker for today, Dr. Zulhasni bin Abdul Rahim. So Dr. Zulhasni completed his PhD industry program in engineering and advanced technology at University Technology Malaysia in 2016. He has published more than 12 international journals during his PhD program in various fields of applied TRIZ systematic innovation methodology and has won several international and local innovation award competitions. He is an international TRIZ specialist under Matrix and has more than 15 years of working experiences in mold design and Japanese electronic manufacturing. He is also a quality expert in automotive industries and a manager of transformation department and currently working as a TRIZ innovation expert and a senior lecturer at Malaysia Japan International Institute of Technology, UTM Kuala Lumpur. So now, without further ado, we will turn the time over to our presenter, Dr. Zulhasni bin Abdul Rahim.
Yeah, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon, everyone. So my name is Zulhasni bin Abdul Rahim, and I will be a speaker for our session today with the topic of problem solving using TRIZ. So I will start.
Yeah.
Okay.
Welcome, Dr. Zulhasni. Thank you for joining us for today.
Okay, thank you very much. Okay, so I'm glad that been invited by the Faculty of Chemical Engineering and Energy, and also I'm part of UTM Center of Engineering Education, CEE, which is my part to contribute back to our organization. Okay. So I think if without further ado, I will share my presentation slide. And I will brief you regarding with our topic today. Okay, so our topic that I will share with you is about engineering problem solving skill using TRIZ. Okay, so what is TRIZ? How we want to learn about this so-called problem solving skill, and how we want to apply in our development in engineering work and also career development. Okay, so this will be the scope of our topic today. Okay, so as you know that TRIZ is actually a problem solving tools, and it helped a lot in terms of what you call developing innovation and so on and so forth. Okay, so again I just repeating what have been highlighted by our moderator, okay, regarding with our previous background of myself. Okay, so I've received my mechanical engineering degree back in 2002, under University Science Malaysia. Okay, and then I further my study in PhD program under UTM, under Razak School. Okay, and at that time I'm what you call embarked on the PhD industry program. Okay, it is a pioneer program that have been organized collaboration between UTM and Proton. Okay, Proton Holdings. Okay, and then regarding with my industrial experience, okay, I have 3 years working in a Japanese electronic company. Okay, and also more than 11 years working in automotive industrial sector. Okay, and then I've joined UTM in 2017. Okay, so almost 5 years that I've served UTM under the Faculty of Malaysia Japan International Institute of Technology here in Kuala Lumpur. Okay, so my current position is senior lecturer, and also I've been given opportunity to actually develop a spin-off company. Okay, a company that have been created based on intellectual property created under UTM. Okay, so based on my research work, okay, I've developed an intellectual property that can be used for commercialization. Okay, and with that, I've established a spin-off company, okay, called Siri Sdn Bhd. Okay, Siri is an acronym for Sustainable Industrial Revolution and Innovation Sdn Bhd. Okay, so currently I'm the CEO of the company, and I've served a lot of industry, government agencies, and even society in helping them to develop their capability toward Industry 4.0. Okay, so meaning that whatever you have learned in university, you have the opportunity to convert the knowledge into something that is we call intellectual property, and create value to your stakeholder, and even you can gain profit by commercializing this what they call intellectual property. Okay, and then my highest achievement is becoming a national expert, okay, in TRIZ, and I will share some case study that I have a project that I have involved. And I am also an expert for Industry 4.0 program under Ministry of Industrial Trade and International Trade and Industry, okay, which commonly known as Industry Forward. Okay, so that is another highest achievement of my career. Okay, so that is a bit of background about myself. Okay, and then why actually TRIZ is been selected as a topic for you, especially for engineering problem solving. Okay, so back in 2014 or 15, okay, the Ministry of Education Malaysia have decided to actually introduce a new topic, a new problem solving tools and technique for our education mainstream. Okay, so I've been involved in this project under the Ministry of Education and start to introduce TRIZ in one of the curriculum called Reka Bentuk and Technology. Okay, design and technology. So this TRIZ tool have been selected by the government of Malaysia, and they asked me to embed it, the so-called tools of problem solving in this subject. Okay, it is firstly introduced in Form 2 syllabus. Okay, so if you have the opportunity to go to the bookshop and find our education textbook for Form 2 under the topic of design and technology, you can easily find TRIZ is the first chapter in the textbook. Okay, so the government of Malaysia is hoping that by introducing TRIZ, it helped our new generation to solve engineering and technical problem more efficient and more effective, and help to actually introduce innovation in Malaysia and also international level. Okay, and then this is the book, okay, that you can try to find it out. Okay, so Reka Bentuk and Technology published in 2018. The first chapter is about TRIZ. Okay, so they have high hope and regards to TRIZ, and eventually it create an impact to our younger generation. Okay, I also been involved in developing Form 3 textbook under Reka Bentuk and Technology, which promoted, okay, what you call TRIZ in our textbook, okay, in our mainstream education. So this is our first project that we try to introduce TRIZ in education level, okay, because most of the application of TRIZ is more towards industrial level sector, okay. So it is very little for us to see a case study or introduction of TRIZ starting at the education level, okay. So this is my first pilot project on introducing TRIZ to MRSM, okay. We have here 4 MRSM, okay. We have MRSM Felda, MRSM what do you call typing, Parit, and also MRSM I think MRSM typing, Parit, Felda, and I think Kuala Kangsar, I think. Okay, so these 4 MRSM have been selected to actually involve in the innovation project. We try to introduce TRIZ, and hopefully TRIZ able to equip them with a skill of problem solving and developing innovation for international innovation competition. Okay, so we have 2 batches that we have successfully conduct in introducing TRIZ, okay, in the school kids. And then one of the biggest impact that we achieved by this pilot study is actually one of the team in MRSM won National Innovation Award in 2016. Okay, so this is one of the proof that TRIZ able to uplift the innovation skill in our student, okay, not just in secondary school, but also in the university level. Okay, so if secondary kids, secondary school kids are able to achieve so much by learning TRIZ, then I believe that all of you able to actually be more what do you call, and can produce more and higher performance in terms of innovation and also problem solving. Okay, and then with that, okay, I've also involved with a lot of project, including what you call government and also non-government sector, okay, in actually strengthen the understanding of TRIZ in the education level, in the national level. Okay, so this is will become a momentum, okay, for Malaysia to actually inculcate innovation and also problem solving skill in the young generation of Malaysia. So beyond that, okay, TRIZ have been deployed in various type of education program. Okay, so this is my work in actually promoting TRIZ, not just in the school level, okay, but also in the diploma level, foundation level, degree, master, and also PhD level. Okay, me myself are doing my PhD on the topic of TRIZ, and it create a lot of huge impact to the industry and also to the community. Okay, so let's explain to all of our audience today about how does my journey uh, progress, okay, when I actually adopt this kind of tool called TRIZ. Okay, so I separated into these three phases. Okay, and throughout these three phases, before TRIZ, during TRIZ, and after TRIZ, okay, I'm emphasizing the problem solving skill up, okay, that I've acquired throughout my experience. Okay, so before I learned TRIZ, okay, I've in working in various organizations, especially in manufacturing sector, production, design, and so on and so forth. Okay, so my first job as a mold designer, okay, I've developed a mold and cavity of plastic injection parts. Okay, and we at that time when I received my first job, okay, I've a fresh graduate that learned so many things in university. Okay, I hope that all of the knowledge that I've learned in the university can be applied in my job. Okay, and then from my university years, I've learned a few things from my lecturer regarding with the theory, regarding with the case study, and so on and so forth. Okay, so once I've joined my first work as a mold designer, I been what you call received knowledge from the theoretical part of my education degree program. I hope that all my knowledge can be applied in what you call my industry. And once I step my foot in the industry, I understand the real world needs, which is not exactly what I expected in my ideal world kind of thing, and not all of the knowledge that I've learned in university, the theoretical part, the derivation, the formulation, and so on and so forth, is being applied in my real job. Okay, so this is a very challenging experience for me. Okay, which I hope so many things from my what you call what I've learned in the university, and eventually is not really 100% apply in my real world practices. Okay, so once I've joined my first company, okay, the things that they value so much is about problem solving. Okay, so they need us as engineer, okay, in developing added value activities and work which is more focused on problem solving. Okay, without a problem, okay, you are not required basically, because everything is run exactly as been intended, been designed. Okay, so it is very interesting that problem solving is one of the critical skill in industry. Okay, if you're able to solve a company problem or organization problem, okay, as a fresh grad, you will have a bigger opportunity compared to other fresh grad that do not have problem solving skill. Okay, so they will depends on what they call what they have learned so far in the university, and getting A's in our examination is not the same as getting A in the industry. Okay, So that will be the challenging part. So, excuse me. According to my experience in learning through my work, okay, there will be a few experience that I've acquired, okay, in the industry, where actually the industry solve problem using try and error, okay. So when they face a problem, okay, they normally call for a meeting, excuse me, and to do to solve the problem, okay. And then once the problem is addressed, they need to monitor the problem, is it solved or not, okay. So this will be a things that are commonly used in industry, okay. So there is a very what you call common practices in the industry when it comes to problem solving, okay. And then one of the common tool that the industry really use is in Malaysia is Kaizen. Okay, so Kaizen is a Japanese acronym for continuous improvement. Okay, so this tool called Kaizen is focused on improving what you call process improvement, process innovation. So there's a lot of tools under Kaizen, such as 5S, QCC tool, Kanban, just in time, quality improvement, and so on and so forth. Okay, so most of the tool under Kaizen is focused on improving the efficiency of processes. Okay, try to increase productivity. Okay, so you can try to Google and find out more about Kaizen. The second part of innovation is Kaikaku. Kaikaku is another type of concept in problem solving that use strategic innovation. Okay, while continuous improvement work in the incremental level, Kaikaku works with a destructive kind of approach. Okay, they have leap kind of innovation and go over the barrier and issue that they are facing in their organization. Okay, so this is two type of problem solving which is commonly used in Malaysia industry. Okay, so most of the industry in Malaysia use Kaizen as their tool. They use Lean, Six Sigma, and so on and so forth. Okay, the Kaikaku concept is rarely been applied in Malaysia because it is a part of the research and development of specific organization, which is considered confidential, okay, and what they call a part of their strategic company development. Okay, so it is very rare for people to actually share their secret in terms of strategic innovation. So when you try to solve problem, okay, especially using Kaizen, okay, you can see here the problem solving technique start with defining a problem, okay, and then next after they define the problem, they will measure, they will collect data, and they will analyze the data, okay, to make sure they're able to find the root cause. And once they find the root cause, they need to come out ideas, concept that able to solve those ideas. Okay, So they need to develop a concept. Okay, they need to develop a solution that is able to solve the problem and overcome the root cause. And once the idea, the concept have been established, they need to apply and improve the situation. And eventually, once the solution have been applied successfully, they need to monitor and control the process. Okay, so eventually from the slide, you can see that we have a very strong element in defining problem and measurement. We also have a lot of strong influence in control, but we have a very weak point in terms of developing effective ideas, impactful ideas, and also idea that able to solve the problem effectively. Okay, so in that part, okay, we try to find what are the tools or the solution to make sure that the problem solving can be deployed effectively. Okay, so this is the thing that we have under Kaizen, under Lean problem solving. Okay, and then we need to complement any other tools that improve the quality of our solution into our problem solving activities. Okay, so you can see under the technique, the tools that they use, they have quality, function deployment, reliability, try and error. Okay, we have brainstorming and so on and so forth. So in existing level, okay, there's always various tools that you can use to solve a problem, especially for engineering or non-engineering application. Okay? So the things that we need to reflect, okay, as a fresh graduate, as a young engineer, okay, so we need to understand, okay, when it comes to problem solving, is there a better, faster, and impactful way for you to solve any engineering or technical problem? Okay, that is the first part. Okay, so if you identify, if you found out there is a way, there's a better way, there's a faster way and cheaper way in solving a problem, okay, it will be very good for you to actually share with us and try to always focus on increasing our value in our organization. Okay. The next question is, what is beyond process improvement? Okay. As far as we know that a lot of what we call problem, okay, is actually can be resolved using the tools. Okay, but what's next? Okay, what actually happened after you achieve the level of improvement? Okay, do you stop or do you move on to a different level? Okay, and then you can also look into the question like how to break the non-routine. Okay, so sometimes routine, okay, have their own challenges. Okay, so we actually look into the element of different way in doing things with a different kind of perspective, and then how to leap above the pyramid culture. Okay, so pyramid is starting with one person, and then they have two, four, and then they become more, and more. Okay, so we need to make sure that we are able to develop an innovation that able to leap across the barrier that we are faced in the current position. And lastly, how to avoid trial and error. Okay, so try and error is an activity, is a work that wastes a lot of our resources, time, and also energy. Okay, if we do this try and error, we need to repeat the process many times until it able to reach the what we call uh, the best solution. Okay, and also the limitation of budget, somehow influence the problem solving activities. Okay? And then because a certain type of industry, especially for chemical engineering, we do not allow, okay, the problem to be solved through what we call unstructured way, okay, and it might cause harm and even what we call big issue in terms of safety and so on. Okay, so this is a short video about my company. I'm not sure if the video is. So the sound cannot be heard, okay, but let me explain to you. This is my time during working in Proton, okay, as an engineer, okay, and then I've been given some assignment, okay, to actually innovate the problem solving way in measuring the quality of the product. Okay, so our product here, this is the car. Okay, we call it body in white. Okay, so the car need to be prepared and to be put in under the inspection jig. Okay, and once the inspection jig is what you call ready. Okay, we will measure the what you call the accuracy of the body measurement. Okay, and then we try to explore more a different way in measuring the quality of the body accuracy. Okay, we use a specific technology that fit in the requirement of our what you call technology. Okay, requirement of our quality control. Okay, so this is where actually we able to have a um, what you call a technology or machine that able to speed up the process of checking body accuracy. Okay, so this is my experience lah. Okay, so now we want to make sure that uh, how does TRIZ able to create an idea in solving the issue in the industry. Okay, so and then we move on to the second part, the part where actually we learn TRIZ. Okay, we've been introduced TRIZ to solve our problem. Okay, so before we have TRIZ, we have Kaizen. Okay, we have a lot of quality tools. Okay, and once we've learned about TRIZ, then we will know what are the potential and also how we use TRIZ to complement our problem solving activities. Okay. So my journey when I start to use TRIZ is during my terms in engineering design department. Okay, so my task is actually to develop a new design that able to introduce cost reduction in the overall design. Okay, so we require enabler. Okay, to actually assist our team and also our engineers. Okay, to actually produce cost saving impact. Okay, and avoid any deterioration of quality and function of the car. Okay, so we have a few things. We have concept, we have model, we have framework, we have methodology, tools, and technique. Okay, so whatever we have at that moment, okay, we try to learn our best to actually produce the biggest impact. Okay, in cost reduction. Okay, so we call it cost innovation. And then we started with layout the foundation of problem solving. Okay, so we started with Kaizen. Okay, so under Kaizen we have philosophy of Kaizen, And then we have model, okay, house of quality. We have model for quality management system. We have model for Toyota production system. And then we try to explore deeper regarding with the framework of problem solving, and then regarding with the tools, which is important for problem solving, and so on and so forth. Okay, you can see that the framework, plan, do, check, action, Pareto. So all of these tools is very important. Okay, for problem solving in the industry. Okay, so that is why we try our best to learn the existing tool before we start learning TRIZ. Okay, so all of the tools and technique have been applied in our organization. Okay, and then one of the good tools for improving problem, okay, related to process is Six Sigma. Okay, Six Sigma is actually a tool for you to control variation in specific parameters in our process. Okay, so by having this kind of Six Sigma tool, it become a framework for us to solve problem. Okay, we have define, measure, analyze, improve, and control. Okay, and each and every uh, process of problem solving is being equipped with a special check sheet. Okay, we have a histogram, check sheet, we have Pareto, flowchart, statistical process control, SPC, and so on and so forth. Okay, so all of these tools help us to measure, okay, the parameter of our process, okay, our condition, and then eventually we will what you call, look into the potential, okay, and the strategy how we able to solve the the problem successfully. Okay, so these are the things that we need to focus on. Okay, and then the lacking part when it comes to Six Sigma is about what you call problem solving activities. Okay, and then it will be important for us to actually understand the tools, trees, and try to complement the improvement on the problem solving process. During my time in 2011, there is no direct source. Okay, when I want to learn trees. Okay, one of the existing organization that adopted trees is Intel in Penang. Okay, so I'm visiting Intel together with my supervisor and meet an expert in using trees for process improvement. Okay, so Intel is an organization in Malaysia that early adopters in terms of trees problem solving. Okay, so as much as we talk so much about trees, we need to know what is trees. Okay, so TRIZ is actually an acronym. Yeah? It's a Russian acronym with I actually pronounce the acronym Teoria Resenia Izobretatelskih Zadaч. Okay, I repeat it again. Teoria Resenia Izobretatelskih Zadaч. Okay, it's a TRIZ, T for Teoria, R for Resenia, I for Izobretatelskih, Z for Zadac. Okay. In English, we call it a theory of inventive problem solving, and in Malay, we call it teori penyelesaian masalah inventif. Okay. So this is the founder of TRIZ. Okay. His name is Jendrik Solvik Altshuler. He's from Baku, Azerbaijan, and he is a science fiction book writer initially. And during World War II, he been what you call instructed by the government, okay, to participate in World War II as a naval officer, okay, and his work related to science fiction, try to analyze new technology in military, okay, and try to actually help the engineer and also what they call technical people to resolve engineering issue related to military technology development. Okay, and throughout his observation, okay, he found out there's a technique, a process of problem solving that help engineer to solve efficiently, okay, related to technical and engineering problem. Okay, so this is the history, the first part, the first situation that Altshuler introduced TRIZ, okay, into into the world. Okay, so I think before we have take a short break, let me explain this the things that Altshuler established, yeah, when he actually developed a TRIZ, problem solving tools. Okay, the first part that he identified from study what you call pattern, the document of technology registration document related to developing weapon and military. Okay, so first he found out that problem and solution repeated across industry and science. Okay, what does it mean? It means that when an engineer try to develop what you call armored vehicle, okay, he will face an issue on what you call safety, which is the bulletproof of the vehicle armor and also the weight of the vehicle armor. Yeah? So this kind of problem, okay, occur in so many types of product and technology. Okay, because when they want to develop a very good vehicle armor that able to withstand any attack from enemy, yeah, missile and also bullet. Okay, the vehicle become more heavier because of the metal armor. Okay, they become thicker and become more stronger. Okay, this issue not happen in vehicle armor like tank. Okay, it also face in developing a what do you call a aircraft. Okay, so the aircraft also need to be bulletproof and the same time it need to be lightweight. Okay, so the issue that they are facing in designing military tank is similar and repeated when they want to design a aircraft. Similar when they want to design a bulletproof helmet. Okay, so this issue is repeated. Yeah? It's repeated across product and also technology. Okay, number two, when they want to develop a new type of technology, the changes of technology is also repeated according to certain type of pattern. Okay, the development of your TV, yeah, is also similar to the development evolution of your personal computer. It also have a certain similarity in terms of trend in evolution and innovation with your telephone. Okay, so this pattern is move in certain similar pattern, similar way and similar direction. Okay, so when you have a repeated pattern or direction, okay, you can apply a similar pattern of evolution in upcoming new product and bring it to a new level. Okay, and also the last part is actually innovation that been defined by Altshuler is innovation is outside the original domain of your problem. Okay, meaning that if I have a mechanical type of problem, a mechanical engineering problem, there will be a faster, better, and cheaper solution coming from outside the domain of mechanical engineering areas. Okay, it could be a better solution coming from chemical, from food industry, from electronic, and so on and so forth. Okay, so by having this kind of three element created by Altshuler, okay, your problem solving activity will be faster, cheaper, and better. Okay, even though this is a technical and engineering problem solving, okay, by learning TRIZ and adopting TRIZ, your problem solving will become more effective and more efficient, especially for technical and also engineering problem solving. Okay, so this is the strength of TRIZ. Okay, when it comes to problem solving. Okay, technical problem solving. Okay, it able to support you. Okay, it able to equip you in your journey towards industry. Okay, so this is the first part of introduction regarding with TRIZ. Okay, so I think we will give the floor to our moderator. Okay, thank you very much.
Okay, thank you so much, Dr. Zahasni. So hopefully everyone has gained something from the first part of our talk. We will give some time for our speaker to take a 5-minute break as well as our respected audience. Thank you and see you in another 5 minutes. Okay, so I hope everyone is ready for the second half of our talk. Dr. Zasni will continue his talk and we will have a Q&A session at the end of the session. Again, you can type your question in the chat box and I'll bring them up later at the end of our session. So now I'll pass the stage back to Dr. Zulhasni for him to continue his talk.
Okay, thank you very much, Dr. Shuhada, for the session. Okay, so let's look into the slide and we will enter the next part of our session. Okay, so as we have highlighted before this, that this is the core part of TRIZ, where actually when it comes to problem solving, your actually your how actually the methods that you want to solve the problem become more easier. Okay, when actually you have this kind of concept. Okay, meaning that when you are facing a problem, okay, it is not a new problem. Okay, it's a problem that somebody already experienced this problem. Okay, so it's nothing new. Okay, it's nothing new. And then the best part is actually the problem that you try to solve it, already have solution, not just one solution but multiple solution. Okay, so if you don't believe, okay, you can try it. Go to the Google pattern, okay, and then you just type the keywords that the element that you have found a problem for your engineering issue. Okay, so for example, the process like pyrolysis. Okay, so there's so many type of pyrolysis, and there's so many methods, technique, and there's so many technology, and so on and so forth, that you can learn from Google pattern. Somebody somewhere somehow already solve your problem. Okay, so this is a very good thing for us as engineer. Okay, we actually not so expert in all of the solution or technology, but we able to use TRIZ as a tool and a technique for us to actually have this methodology to capture what actually the solution is already available in around the world. Okay, and for number two, okay, for number two, that the technology is we have historical record. How does the technology change? Okay, so if we have a new product, okay, that we believe that we want to involve, we want to improve to another level, okay, eventually we will use this kind of technology pattern, okay, and try to predict what is happening in the future. Okay, what's next after the smartphone now. Okay, so we'll use this, okay, to actually provide us the glimpse of the concept of future smartphone. Okay, and another part is number three, is where actually innovation solution is come outside from our expertise. Okay, so maybe all of you is learning engineering, chemical engineering, and it could be like the solution that might come, a better solution that might come from non-chemical engineering. Okay, so we are not an expert outside mechanical engineering, but when we use TRIZ, it helps you to go outside your comfort zone and try to learn new things that able to solve your problem. Okay, so that are the things that we can eventually learn and take benefit from TRIZ. Okay, so after Altshuler study about 200,000 pattern, okay, Altshuler found out that there is a lot of innovation that come outside the box. Okay, and there's also a lot of solution, technical solution, that we can use to solve our problem. Okay, so Altshuler challenged me and also challenged you to solve technical and engineering problem within 15 minutes. Okay, so sound like overclaim, sounds like overclaim. Okay, so this is what the confidence level that Altshuler have in TRIZ, that this tool able to solve your technical engineering problem quickly and effectively. Okay, so this is the things that also a challenge for all of you. Okay, so TRIZ have a lot of tools. Okay, you can see here the tools for problem solving, defining problem, try to solve people problem. Okay, try to make a system more robust. Okay, try to develop new things, new product, and so on and so forth. Okay, so if you are interested, you can communicate with CEE or maybe your faculty, and try to ask if you are interested to learn this TRIZ tool. Okay, we have level 1, level 2, and level 3 for you to actually learn this kind of tool and equip yourself with problem solving tools and be ready for your industry experience. So this is my certificates. Okay, International TRIZ Association, TRIZ level 3. Okay, so I've learned under the guardianship of TRIZ Master, Professor Dr. Sergei Ikovenko from MIT. Okay, so I certified back in 2016, and it is a very interesting experience that I've learned. Okay, and be certified under International TRIZ Association. Okay, so we also provide similar certification for in Malaysia. We have Malaysian certification, and also under UTM Center of Engineering Education. Okay, so please contact us if you are interested to have this kind of program for your career development. So when I've been introduced with this kind of tool, there's a few things that I would like to share with you regarding with problem solving skill. Okay, the first part is a change of mindset. Okay, so in solving a problem, okay, it is very difficult for us to change our mindset from student to engineer, from consumer, user to inventor mindset, designer mindset, or engineer mindset. Okay, so this is the first part that is very challenging for me personally. Okay, and I will explain a bit later what does it mean, example, and so on and so forth. The second part is actually the system base. Okay, so on the system base, we look into all engineering element. Okay, is focus on the system base. Okay, where actually we look all the problem, all the concept. Okay, of problem that you will encounter in the context of system. Okay, it makes your problem solving become more objective, become more easier, become more effective and impactful in terms of problem solving. Okay, and then the third part is actually find the true root cause. Okay, so this is very difficult for people, normal people. They try, normally they will do assumption, guessing, okay, and try to find the root cause based on the assumption. And most of the time, the assumption is not right. Okay, this is very, very challenging. Okay, so by having a change of mindset, by having a system-based approach, we able to find the true root cause easily and faster. Okay, and then the fourth one is actually to try to convert our ideas into something that is workable, implementable, and practical. Okay, so this is the part which is require creativity. Okay, require your mindset. Okay, to be what you call able to translate the concept or ideation into something that is practical and implementable. Okay, so this is the thing that you need to achieve. Okay, the fifth one is actually try to convert all the element around you, all the resources around you to become solution. Okay, because sometimes when people try to solve a problem, okay, they will use new things. They will ask new system, okay, new solution, and so on and so forth, which is costly. Okay, so in TRIZ we use existing system, we use existing resources. Okay, within the system itself, we can find solution. Okay, and the last part is execution. Okay, most of the problem solving you can implement it. Okay, but not just doing it, but to make sure that the problem is resolved completely. Okay, without any repeating, or the problem is coming back and not solve the issue effectively. Okay, so the like here are some detailing for you to ponder. Okay, the first part is the skill to change your mindset. Okay, try to develop your mindset in the formative way. Okay, because when we are in school, in education level, okay, we are being assessed with examination and also coursework. Okay, at the last part of the program. Okay, so we call that summative. Okay, so actually for human, we actually try to develop our mindset, grow in the what do you call organic way. Okay, it's not like we try eventually with quick and fast you become smart, and you become what do you call creative, or able to solve problem effectively. It requires some organic approach that you need to form your mindset. Okay, as much as you grow and your experience with your learning, okay, it able to create a very good mindset. Okay, from unsolved problem and then you learn how to solve your problem, and eventually you able to solve your problem effectively. Okay, so in TRIZ theory, your problem is not new. I have repeated this again. Okay, and there is more solution outside your boundary of knowledge. Okay, that's why pattern is the highest level of document in technical and engineering value property, because it is a very what do you call, it can create high value commercial and profit. So this is important. This is important. And then when I say organic approach in solving a problem, okay, you can see in the slide that our mindset, when we try to understand things, our mindset will grow diverging. Okay, diverging. So we open up our mind and actually try to understand as much as possible the situation of our problem. Okay, so that is our technique. Okay, and once we understand the issue properly, okay, we need to converge our thinking method and focus on the real true root cause. Okay, because in the problem solving there's only one root cause. Okay, it cannot have a lot of root cause, or you cannot focus to effectively solve the issue. Okay, so we need to find a specific true root cause. Okay, and then once you find the true root cause, you need to diverge back your mindset and try to find idea. Okay, and then try to find idea to solve the issue. Okay, and once you find you have a lot of idea, okay, you need to converge back and try to develop one effective solution. Okay, so this is the technique, diverging to understand, converging to find a root cause, diverging for ideation, and converging to establish the final solution. Okay, so this is also a technique that we use in TRIZ by having this kind of tools to help our student and also our problem solving. Okay, so this is a short video. Okay, I'm not sure it is the sound is okay. Let me try first. Oops. Okay, so that is a video for you. You can what do you call, visit the YouTube channel. Reacted using Powtoon. Okay. And then that is the things that we need to look forward. Okay, where actually the common what do you call process, or when we try to find when we want to solve a problem, okay, we will use brainstorming. Okay, so brainstorming is very popular tools for creating ideas. Okay, but it is not doing some understanding, defining a problem before we use the brainstorming. Okay, so there's a lot of what do you call, assumption. There's a lot of wild ideas and so on and so forth. Okay, but for engineers like us, okay, we need to make sure that if we able to solve our problem in the what do you call objective manner, okay, we able to easily solve the problem. Okay, which part is not okay, which part is issue, and so on and so forth, and eventually it able to speed up the process of our problem. Okay, so that is the four element of brainstorming versus four element of TRIZ. Okay, which part actually help us to solve our problem faster, better, and cheaper. Okay, so that is the things we need to change our mindset and to become inventor, to become engineer, to become designer and manufacturer. Okay, not put ourselves as a user or consumer. Okay, we are higher level than that. Okay, and we hope that by changing our mindset, we able to solve the problem better. So, and then the second skill that that become challenging during my time is actually to convert all the problem into a system base. Okay, so in TRIZ we have three type of category. Okay, a system which is refer to the product. Okay, like chair, computer, and so on and so forth. And then we have subsystem. Subsystem is the component of the system. For example, in the computer component, we have monitor, we have keyboard, we have CPU, power supply, and so on and so forth. Okay, so this will be the subsystem, the component of the computer. And then we have super system. Okay, so the super system is outside the system. Okay, so for a computer, we have table, we have chair, we have a person that use the computer, and so on and so forth. Okay, so whatever outside the system of the computer is called super system. Okay, so by categorizing this kind of concept, okay, we able to identify where does the problem position or located. Okay, so that is why we use this system base. Okay, and each and every system and component have their own function. Okay, so if they unable to carry out the function well, it means that the problem is what do you call, is exists. Okay, the problem is exists. Okay, so it is very easy for us when we adopt this so-called system-based approach. We can quickly identify where does the component, the subsystem, the subcomponent, okay, have problem. Okay, and what kind of problem that they have. Okay, the functionality, and so on and so forth. Okay. And then, for example, when we look into this kind of thing, okay, we have, for example, fan, okay, functionality of the fan, okay. So you can see here, okay, the main function of the fan. If you are a user kind of mindset, you say that the function of the fan is to cool down. Okay, so that is the effect of the using a fan. Okay, not the root cause using a fan. Okay, and then the real function of the fan is actually to move air. Okay, by spinning the blade, okay, rotating the blade, it able to move air from the back to the front, okay, with a certain speed, and it able to blow the heat, okay, blow the air, and it become the effect is cooling, cooling effect, okay. So we need to make sure every time we able to try to solve a problem, okay, we need to make sure that we understand the system and its functionality. Okay? If we don't get the functionality or the understand of the system correct, then it will create a misunderstanding and a bigger issue. Okay, while you are unable to find the real root cause, okay, you are trying to solve a wrong problem. Okay, so this is the challenge. Okay, same with eyeglasses. Okay, so what is the main function of eyeglasses? Okay, if you ask normal people, they will say that eyeglasses is to see clearly. Okay, so to see clearly is the effect. Okay, is the effect of wearing eyeglass. Okay, the things that make you see clearly is because of the glasses able to reflect light. Okay, when they able to reflect light, okay, the focal point is what you call is focus and targeted. Okay, and eventually you able to see things image clearly. Okay, so this is the thing that important for us when we want to solve engineering problem. Okay, we need to understand clearly what is the function, and we need to understand clearly what is the system. Okay, feel free to ask any question, yeah, if you have anything to ask. Okay, for those who ask question, thank you very much. Okay, the simple tool, pen. Okay, so what is the function of the pen? Most of the student or engineer will say to write. Okay, that is wrong. Okay, wrong function. The actual function for pen is actually to deploy ink or to make marks. Okay, if you unable to deploy the ink, distribute the ink, then it is a useless pen. If you unable to reflect light, it is a useless eyeglass. Okay, if your fan unable to move the air, then it is a useless fan. Okay, so by learning TRIZ, okay, we able to understand the actual function of the system, okay, the true meaning of the component and the functionality, and this able to make us clearly understand objectively what does the system is all about. Okay, so this is the challenges for us as engineer, and try to solve the problem, okay, with correctly. Okay, if you unable to understand it correctly, then you will eventually get the wrong idea, okay, the wrong information. Okay, so please make sure that if you have the opportunity to learn TRIZ, okay, you will actually able to what you call understand how to solve the problem effectively. Okay, how to solve the problem effectively. Okay, so the next part is the how does we actually understand all this what do you call new way of TRIZ way in understanding the issue. Okay, So by having this kind of tools, okay, we able to make our process of understanding the situation become more objective, become more effective. Okay, how does the tool works? How does the system works? Okay, what actually inside the system? Okay, there must be a important component. Okay, inside the system. Okay, that make the function, and also there is important component inside the system that create the problem. Okay, so we need to understand the system, which component that carry the function, okay, which component that bring the problem, okay, and how we want to tackle this kind of issue from the component perspective. Okay, so this is how we use TRIZ. So, and in conclusion, for the skill set number 2, we try to change our mindset from the consumer mindset into the inventor mindset. Okay, we try to see system more objective instead of we just looking at the subjectivity of the issue. Okay, so this is important. This is help our problem solving become more better and effective. Okay. So this is a case study, okay, that I've done in my previous company, in my previous organization. Okay, we try to develop new things. Okay, so we ask people what they want in future. Okay, they will face great difficulty. Okay, because they unable to see what happen in the near future or the next future. So if you have a user mindset or consumer mindset, you have a limited foresight, okay, in understanding the future development of technology or innovation. Okay, but if you use TRIZ, okay, your mindset have been put into a systematic innovation, okay, and help you to forecast what will be the changes of future technology or future system. Okay, so in this slide, to show you, there's a monolith bumper of the car, one joint bumper, multi-joint bumper, elastic bumper, gas type bumper, fuel type bumper. Okay, but there is no type of bumper under powder concept and liquid concept. Okay, so this kind of foresight, okay, is interesting for us to explore. Okay, and when we explore this kind of thing, okay, we able to find opportunity. When your bumper crash into an accident, okay, when your liquid bumper able to reform back the shape into the original size. Okay, so you don't need to spend 3,000 or 300 or 700 ringgit to repair your bumper, because it can change back shape into the original form. Okay, so this is one of my research during my time in Proton. Okay, so let's go to the third skill. Okay, find true root cause. Okay, so once we understand, once we get a very good mindset, then we try to look into the system-based kind of thing. We try to see the component and the functionality. Okay, it is easier for us to find the root cause. Okay, which is the culprit, which component is the culprit. Okay, most of the experience that I've encountered and solving a problem, they will show that the root cause of the problem is human. Okay, they will show that human error is the root cause of all type of problem. Okay, all type of problem. Okay, so they blame human. Okay, they blame human easily because they will take action easily. Okay, and then they will solve, and actually they don't solve the problem. Okay, so this is a very challenging. Okay, very challenging. Okay, because it is not solving the problem. Okay, when you blame human. Okay, when you blame human. So we need to know the component, we need to know the function, we need to know the process. Okay, we need to know the areas of improvement. Okay, so on and so forth. Okay, then we know actually what will be the issue. Okay, not blaming other people, not blaming the government, not blaming your lecturer or even yourself. Okay, and so on and so forth. So this help you to actually focus on the problem. Okay. So for example, puncture tire, your tire got punctured. Okay. So before your tire got punctured, there will be sequence of event. Okay, there will be sequence of event that leads towards the problem. Okay. Before that there is no issue. Your tire is running properly. Okay, and no puncture and so on and so forth. Okay, and then the tire is rolling on the road. Okay, still no issue. Okay, and then the road is different from one area to another area, still no issue, and eventually your tire meet things called nail. Okay, so the nail interact with the tire. So how does the nail interact with tire? Okay, we need to go deeper. Okay, that create the issue. Okay, some nail interact with the tire and do not create puncture. Okay, and some interaction between the nail and also the tire create puncture. Okay, so we need to specifically identify what kind of interaction that create the problem. Okay, so in skill set number 3, okay, when we try to focus on finding the real root cause, okay, we need to go into the system based component, function, shape and feel. Okay, this is more engineering, more technical for you to actually find the real root cause. Okay, and don't blame other people. Okay, you need to blame the system, you need to blame the component. Okay, for you easily to take action as engineer, as designer. Okay, as inventor. Okay, so this is your job. Okay, your job is not to blame people. Okay, people is weak by default and they always make mistakes. So by blaming people do not solve the problem. Okay, so you need to change your mindset. So this is my experience. Okay, when working with engineers. Okay, we find the best people in the company, focus on the high value product, developing an innovative problem solving event, and achieve what they call the outcome of our program. Okay, so this is a very good example, okay, of the program. The company achieved 1.8 million cost reduction, okay, from applying TRIZ into the engineering activities. Okay, so this is the achievement we achieved so far, and the achievement is increasing year by year. Okay, from 1.8 to actually 2.1 and 2.5, okay, million per year on the cost reduction. Okay, without jeopardizing or trade off the quality and also function of the engineering system. Okay, and the next is skill number 4. Okay, try to convert your concept ideation into a real solution. Okay, so when we learn a few what you call concept that have been successfully implemented, okay, we try to use our creativity, okay, and convert our ideation into something implementable and practical. Okay, so kids have a lot of good creativity and imagination, while adult, okay, have limited and little creativity level. Okay, why? Because they have a lot of experience and knowledge that stopping them to become imagination, to use their imagination and to be creative. Okay, so we need to go outside the box. We need to learn TRIZ. Okay, and then we try to enhance our creativity skill. Okay, to develop a lot of high impact ideation. Okay, so the process flow of TRIZ ideation, okay, starting with the specific problem, okay, and then we generalize the problem, and then we make a model out of that problem, okay, and then we have developed concept solution, and then we have specific solution. Okay, that is our approach in actually solving the problem. Okay, if we do not have what you call if we do not have the steps, okay, we eventually what you call do try and error. Okay, we do try and error. So try and error do not actually is not a very good what you call tools for you to solve a problem. Okay, you directly jump into the conclusion to the solution without considering proper analysis and understanding of the real issue. Okay, so this is the thing that we need to aware. If we go try and error, it could be probably that you're able to solve the problem quickly, but there is also a risk, okay, for you that the solution is not 100% solved. Okay, so you need to make sure that this thing are not really what you call uh, what you call waste a lot of resources and your time. Okay, so right at the first time is different from the try and error. Okay, right at the first time you are properly use trees to establish your problem solving process, while what you call try and error, you might get lucky that your problem is solved, and also unlucky that the problem is not solved 100%. Okay, so this is the risk that you will face. Okay, so one of the concept in TRIZ is 40 inventive principle. Okay, in engineering, okay, there is 40 concept, okay, that you can use, okay, as a concept that you can use to adopt in your problem solving process. Okay, so these are the things that we can learn. Okay, we can adopt trees immediately. Okay, so there's a 40 solution there. Okay, this is one of the case study that I've learned, okay, in my previous work. When we have preve, we have ball bearing. Okay, and then from there actually the ball bearing create a lot of problem. Okay, and then we need to maintain the lubrication and so on and so forth, and eventually the ball bearing become worn out. Okay, and fail. Okay, so this is the thing that we try to avoid. Okay, and then from there actually we try to make the system without the ball bearing. Okay, it become a sleeve bearing, and then we change what you call the bearing coated with Teflon. Okay, and then we try to actually eventually become a polymer bearing. Okay, so this is the thing that we have regarding with the issue lah of the bearing. So without the ball bearing, okay, we do not have what do you call we do not have issue regarding with the um, failure of the ball bearing. Okay, so this is very very interesting project. Okay, so and then another thing is on the solution within the resources. Okay, this is the fifth kind of issue. Okay, and we try to actually use existing resources to actually solve our problem. Okay, we try to actually forecast the future, and by understanding the future, the solution might turn out not just one solution but a lot of solution. Okay, this is a very interesting process. Okay, so there is a 10 prediction for you to forecast future. Okay, and eventually solve your problem effectively. Okay, so this is the things that you can learn from TRIZ. Okay, so this is a case study that I will share with you. Okay, how we actually try to evolve headlamp, automotive headlamp, different type of headlamp, different type of trend, create different type of innovation technology. Okay, so this is the very interesting project that we able to forecast even beyond our domestic or Malaysian market, but also at the international innovation technology. Okay, so this is my research work thesis. Okay, when I doing PhD. Okay, so where actually there's a lot of project that we have so far. Okay, when it comes to innovation. Okay, and we have achieved so much when we have a innovation problem solving kind of activities. Okay, and then from there also we have developed new technology. Okay, from the what do you call, from other people's pattern. Okay, and then we able to reduce weight of the car. Okay, we try to reduce variation of the product and so on and so forth. Okay, eventually I've completed my PhD lah, okay, using this kind of tool. Okay, so in a nutshell, when we adopt, okay, when we adopt TRIZ, okay, we also need to improve our way of thinking. Okay, we need to improve our methods. Okay, in problem solving. Okay, not just using common kind of way, which is try and error, do a lot of assumption and so on and so forth. Okay, that is not a problem solving way for engineers, for technical. It is very good and proper if we able to solve problem solving with objective kind of mindset, okay, approach, tools and technique. Okay, so by using TRIZ, it helps you to solve engineering problem faster, better and cheaper. Okay, so after I've learned this kind of tool, okay, so I've involved with a lot of what do you call national project and program. Okay, my first work is in 2014. Okay, been a part of national innovation agenda. Okay, under Ministry of Prime Minister Office. Okay, under EPU, where the problem is no, the TRIZ become the core program for innovation and human capital development. Okay, I've also helped MPC, Malaysia Productivity Corporation, to change their mindset from productivity mindset into innovation mindset using TRIZ. Okay, this is the work that I've contributed in my previous organization. Okay, we able to achieve 13 million cost saving per year by applying TRIZ. Okay, we also able to introduce TRIZ in mainstream education program. Okay, So all student that take research reka bentuk and technology will eventually learn TRIZ. Okay. So hopefully that all of you also have the opportunity to learn this kind of problem solving too. Okay. So we also apply TRIZ at the industrial standard. Okay. We develop a SIRIM 8. Okay. Develop a standard policy helping organization. Okay. In the industry, we also use TRIZ in developing Industry 4.0 instrument, okay, and forecast the future development of technology, okay, for each and every organization in what you call in Malaysia, okay. So this is a short video about our achievement.
Imagine your industry. You've embraced Industrial Revolution 4.0 and automation. Believe me, we can become a very successful state. That we need to be ready for the next generation of things.
A lot of our industry now is moving forward into Industry 4.0.
Technology itself is very crucial for us to be able to be more competitive. It's already part of modernization. The industry must go forward.
To participate in the Industry Forward assessment is because we know where are we going.
To assess our readiness level, whether we are really ready.
All angles of manufacturing, management, and human resources is covered.
We know where the gap are so that we can make our plan how we want to move forward. It also has shortened our period to assess our readiness and expedite our process to adopt the Industry 4.0.
Basically, it's to make our company relevant and sustainable in the next 10 to 20 years.
And that is very important because everything moves so fast. You have to catch up.
This is about embracing the new industry. We can still do this if you are ready to embrace the Industry 4.0.
Okay, so yeah, you can see me in here, I think. Yeah, that's me. Okay, so we actually help CTRM, okay, to actually improve their Industry 4.0. Okay, so that is our achievement by adopting TRIZ. Okay, so there's a lot of things that we have done. Okay, we are developing skill for future generation. We are developing standard. Okay, we are developing a spin-off out of it. Okay, we also able to secure very high value grant. Okay, related to innovation. Okay, and eventually it able to create impact, not just in Malaysia but also at the international level. Okay, so that is a bit about my sharing. Okay, for those who are interested to know more, okay, about TRIZ, okay, please feel free to WhatsApp me. Okay, contact me in my WhatsApp. You can join the Facebook, and you can also what do you call visit my YouTube channel. Okay, to learn more about TRIZ. Okay, so that's all from my part. Okay, thank you very much. Okay, for the session, and I will give back the floor to our moderator for our next session. Thank you.
All right, thank you very much, Dr. Zasni, for the interesting and fruitful talk. I'm pretty sure everyone here has gained a lot of knowledge from your presentation. And for your information, Dr. Zani, most of the students joining this webinar, they are the first year student undertaking Introduction to Engineering and Industrial Seminar and Profession courses. So now they are currently working on a project entitled Be Wise with Microplastic. So basically for that project, they need to study how behavior and a lifestyle contribute to microplastic pollution and the effects on health and environment. And then they also need to propose an innovative engineering solutions that would alleviate the microplastic solution problem. So I really hope that everyone, especially the ISP and IT student, they can implement this TRIZ technique to help them in their project. Now we will go ahead and take some time for the Q&A session. So just a reminder for the audience, please be sure to type your questions into the question box. I think it looks like we have a few questions. So yourself asks, is a challenge in the ideal world apply to the challenges in the real world?
Okay. So thank you, Yusuf, for the question. Okay. So the ideal world is actually the world that we as a fresh engineer expect. Okay. So we expect that by graduating from UTM, okay, we will get a very good job, a very good position, and we hope that we have been paid, okay, like 5,000 ringgit or maybe 7,000 ringgit, or maybe Sing dollar, okay, and we will receive the job immediately, okay, after before we graduate, something like that, okay. So the expectation is too high even for some fresh graduate, okay, and with the you just been equipped with a specific knowledge from the degree program, okay, which is accredited by UTM, by the MQA, and also by the Board of Engineer. Okay, so it is a general foundation, basic knowledge of engineering. Okay, but once you go into the real world, okay, the issue will be different. Okay, not 100% different, but some of your knowledge that you have learned in chemical engineering might not 100% been applied, okay, in the industry. So that will be an issue there, okay. So even my first job as a mold designer, okay, only paid like 1,200, okay, and then the other guy with different background but same fresh graduate, okay, got 1,500. Okay, so it's unfair. Okay, so different universities sometimes been treated differently. Okay, even though both of us do not have similar experience. Okay, so this is the things that you need to prepare yourself. Okay, between the ideal world, which is your perfect world, yeah, and also the real world, which have a certain deficiency and shortcoming. Okay, so you need to prepare yourself and try your best to be ready for the real world challenges. Hope that answered the question.
All right, now we'll move to the next question. Irilyn, I think there's a quite few question that the audience asked that quite similar. So Irilyn, I think after this, Jorgen, Javier, and Anik, they asked a quite similar question where they want to know how to implement this theory as engineering students and also in daily lives. And they want to know like which organization is practicing this theory and is it common to use this theory in a workplace or in their organization.
Okay, thank you very much. Okay, so regarding with the first question, okay, how we want to apply this in our study and also in our daily life. Okay, so normally when we face a problem that cannot be solved by money, cannot be solved by time, okay, cannot be solved uh, by any critical resources, that is not disposable. Okay, for example, something that that money cannot solve it, time cannot solve it. Okay, so there will be a big, huge problem. For example, when we visit a company, they mentioned that this problem cannot be solved even after 10 years, the problem cannot solve. Okay, so same with our daily life and our study. Okay, some problem which is very difficult for us to solve. Okay, but remember that the first part of the element in the TRIZ, your problem is repeated, means that somebody somewhere already solved your problem. Okay, you just cannot find the solution. Okay, so this is the thing. The problem, even some problem that involve life. Okay, you cannot waste life because you want to try and error. You cannot waste your life. You cannot waste your money because you have limited money. You cannot waste time because time is very precious. Okay, so when you are in the critical situation, TRIZ is very effective for you to use. The rest is actually for you to decide. Do you want to take the solution or do you don't want to take the solution? That will be your challenge. TRIZ able to show you the solution, but it depends on you. It will show you the proven solution, but it's up to you to take or not to take the solution. Okay, so that is the first part of Irlin's question. Okay, the second part of the solution, this question is what actually?
Uh, like which organization is practicing this theory? And also,
Okay.
is it common to use this theory in their workplace?
Okay. So I think the most there's a lot of big company that use this. Okay. One of the biggest is Samsung. Okay. You tried Samsung TRIZ. Okay. So how does Samsung able to overtake Apple? Okay. So one of the strategy, you will search for, you try to search in the Google for Samsung TRIZ. They will show you their strategy. Okay, their strategy to what do you call overtake Apple, what do you call big companies like Apple. You can also look at NASA entries. You can also look Siemens entries. You can also look Philips entries. Okay, but most of the strong adopters of trees is in the Korean company. Okay, we have LG, Samsung, Hyundai, Kia, Posco. Okay,
Oh, they are all big companies. Huh?
they are all big companies. Okay, even they are acquiring talent around the world that have trees. Okay, I have also have tried to apply. Okay, but my PhD terms is not really complete. 5 years. Okay, so they are really looking at the talent of trees. Okay, so please try to learn the case study. Okay, how actually they use trees to make their company bigger and stronger at the international level. And in Malaysia, we have Proton, Intel, we have Infineon, we have Texas Instrument, we have Dyson, we have Harta Lega, JKR, we have a lot of Malaysian industry and also government agency adopting this. So hope
Oh,
that
that's very
answers it.
interesting.
Yeah.
I actually work at Hatalega before I work here though for 5 months, and I still remember they are practicing that Kaizen thing. So that really helped the researcher there to work because they want the workers to not delay like as they want us to finish one job within a specific time, not like you um uh like you say you want to finish it in 1 year. That one they prefer to finish it like let's say 3 months. You have your own milestone, and then you see whether you finish it or not. So and then if anything happen, then you can see what's the solution you need to do. So I think it's very effective to use this practice. So we'll see our next question is from Arshad. So Arshad asks whether we can apply the TRIZ method for all type of mathematical problem.
So regarding with mathematical problem, we need to look into the context. Okay. So what kind of mathematical problem? You are trying to develop a formulation, derivation, you try to actually apply mathematics kind of thing, or industrial mathematics. Okay. So we are more towards problem solving that also involve a certain level of algorithm.
Mm.
Okay, so we have a tool. We have TRIZ. Okay, TRIZ. There
Mm.
is ARIZ. Okay, called algorithm Resenya Isobetatistic Zadach, where actually they give you algorithm how to solve problem. So whatever problem you put in the algorithm, they will give you solution automatically. Okay. So it's like a calculator for problem solving. You key in the number and then pop, they keluar. They show you the conceptual
Mm.
solution. Okay. So the concept is there. The concept is there. Okay. So direct application might be depend on the context. Hope they answer the question.
Now we'll move on to our next question from Tariq. He asked whether is there any theories for problem solving, or is TRIZ the only theory that can be applied for problem solving? I think it's quite similar to the previous question, right? But the Zasni can add more if you want.
Okay, so actually we have a lot of problem solving tools, and not just theory.
Mm.
Okay, so we have design thinking, which focus on human-centered kind of problem solving. We have computational thinking, which more focus on IT kind of context. Okay, we have a lot of these tools. Okay, the different part, the unique part of TRIZ is actually it able to solve problem in the technical kind of problem solving, which is suitable for engineers. Okay, so design thinking is suitable for what you call marketing, branding, or maybe kind of thing. Computational thinking is focused on developing algorithm, okay, and so on and so forth. So we have a lot. We have a lot. So it depends on the context, which actually suitable for our problem solving activities. So in engineering technical problem, TRIZ is one of a very good tool to for me to recommend. Hope answer the question.
Yeah. The next question will be from Faris. He asks, what is the difference using trees for problem solving than just use or by using critical thinking?
So I have explained for almost 2 hours about TRIZ. Okay, let's look
Hmm.
into critical thinking. Okay, so the critical thinking is actually a technique for you to be critical. Okay, on the situation of the problem and also the solution of the problem. Okay, so in understanding the situation, okay, we are not really uh, digesting everything, okay, what have been told to you. Okay, if you are top management, when people presented you the background of the problem, okay, you use this critical thinking to probe in, to investigate, to validate, to verify. Okay, as a top management, so to make sure that this problem is really a problem, okay, and it is a genuine problem, it is a valid problem. Okay, and if you use critical thinking in the solution, okay, everybody throw their ideas and solution. Okay, but is it truly effective? Is it, again, the validation, the verification, the confirmation is a part of the critical thinking focus. Okay, so critical thinking is not developing idea. Okay, it's not used for developing idea. It's not for what they call the developing concept. It is actually to validate, okay, to verify, to actually test or to argue. That is a part of a critical thinking that been used for problem solving. Okay? So most people do not like people with critical thinking, because it is their sometimes the criticism is negative, and sometimes the criticism do not constructive, do not give solution. Okay, they just critique for the sake of comment, complain. Okay, so it is not a very good kind of thing. So hope answered the question.
Okay, thank you, Dr. Zasni. Now we'll move on to our next question from Lim Chi Jie. How our solution can be tested and refined to ensure that it is effectively solve the problem by applying this TRIZ theory.
Okay, so remember the first element of TRIZ, problem and solution is repeated across industry and science. Okay, so meaning that if whatever you have a problem, okay, you need to analyze the problem, and then using TRIZ, be able to provide you the conceptual proven solution, okay, which have some similarity. Yeah, so those that have registered in the patented document, that they already use the solution to solve similar problem like you have. Okay. Now, does it proven? So basically, a testing is one of the technique that we cannot what they call we cannot ignore. Okay. We need to actually verify. We need to test. Okay. The proven solution, maybe it is proven in their area. Okay, but does it proven in our area, our concept, our modification, our application? Okay, it could be somehow different, or maybe different a bit. Okay, so testing is also needed. Okay, but the issue of try and error will be reduced. They will be eliminated. Okay, why? Because this has shown you the proven solution that they have already established before. Okay, so it is easier, faster that you use the proven solution to adopt in your actual problem. So that is how actually the things can be used by using this. Hope answered the question.
The next question would be from Irisha. So may I know how efficient the TRIZ method is? I think it's quite similar to the previous question. Would you like to add more, Dr. Zasni? We'll move on to the
Okay.
next question.
Okay, just a bit. I think yeah, if I'm explaining based on my case study, it is efficient, it is faster, based on my experience, and I recommend you to search other company like Samsung and so on and so forth, how fast they able to develop innovation. Okay, that I will explain in another lecture lah. Okay, the case study, how actually they able to strategize, to speed up, to accelerate technological innovation. Okay, compared to other type of company that do not use this. Okay, so hope that answered the question.
Okay, move on to next question from E. Meng Han. How to ensure that we are, as expected, to be an engineer well equipped with the skill through the internship and daily academic works?
Yeah. So if we have completed our what you call program, degree program, each and every one of us is equal as a fresh graduate with a different kind of CGPA and so on and so forth. Okay? But once you are embarking in the industry, okay, they will not just looking at your resume, they will ask you for interview. Okay, and if you're able to what you call show that you have a problem solving skill that is very significant to the organization, okay, you will be identified as a high value candidate because you're able to solve, you are ready to solve with this kind of skill, okay, to solve whatever problem that we are facing in the organization. Okay, so this is the thing. When we are kindergarten, when we are elementary school, when we are secondary school, even we are in the university level, there is no subject called problem solving. Okay,
True.
so they ask you to do this thing, this project, and so on and so forth. But once you go into the industry, they look forward that you able to solve production issue, defect issue, quality issue, process issue, and so on and so forth. Okay, so this is the
Yes.
thing that the missing link for engineers. Engineers are meant for problem solving. Okay, so hope that answered the question.
Another question from Magat. He asked, how can we as students improve and know we have fully mastered these TRIZ skills to fulfill the needs of industry and technology out there?
So actually, it depends on the requirement. Depends on the requirement. Okay, because each and every organization have different requirement. Okay, some organization is if you work in what do you call operation production. Okay, they will ask you to use this tool for solving production issue. Okay, if you are working at the R&D, it will be different. Okay, if you are working at the oil and gas, will be different and so on. Okay, so the needs will be different. Okay, so but the when we talk about generic skill of problem solving, okay, this will be common. Okay, because you are the you know the methods. You might because you are a fresh graduate. Okay, you might not get the actual real experience because you are new. Okay, but you have the methods. Okay, so you use your methods, the skill of problem solving in whatever industry needs. Okay, either for solving a problem in production, improving quality, increasing sales, develop new product, design and testing, or whatever. Okay, so if you master the methods, you're able to use this in any type of industry. Hope that answered the question.
Okay, I think we'll have our final question from the audience. From Ivan Young, he asked, may I know what is the challenges and difficulties when learning the TRIZ skill?
Okay, thank you, Yong. Okay, so again, in my presentation, if you follow, okay, there's a 5 thing that become a challenge for me. That's why I'm not lecturing you what is risk. Okay, I'm actually giving you the experience. Okay, when you take a step in learning these trees, there will be a challenging in mindset, understanding the system perspective, identifying the real root cause, okay, and so on. Okay, but the first main hurdle is challenging the mindset. Okay, try to change your mindset to become engineer, designer, inventor in a true form. Okay, and you will able to see things clearly in whatever shape or form of engineering or technical problem. It is very easy for you to capture, to understand, and also to tackle the problem in a very professional manner. Hope I answered the question.
Agree with you, Dr. Zahani. So it looks like we've covered all of our questions. Is there anything else Dr. Zuhasni would like to cover before our wrap up?
I think first of all, I would like to appreciate your what do you call involvement in by the student and also the organizer for inviting me to share this kind of knowledge, where this is very important knowledge even for the 21st century. Okay, when World Economic Forum highlighted the top 10 skill for what they call future job. Okay, the top 3 is solving complex problem solving. Okay, so this is very important, very significant, very critical for all of you. Okay, and hopefully it is not stopping here. You will try to search, learn for yourself. Okay, about TRIZ, and also you can also contact your what they call your faculty or even CE to organize UTM TRIZ level 1 workshop. Okay, so I wish all the best for everyone, and thank you very much for the opportunity.
Right, great. Thank you everyone for your active participation in this webinar. We appreciate you being here. Thank you again, Dr. Zuhasni, for joining us today. I hope everyone enjoys the program and hope to see you again next time. Let's end our webinar with Tasbih Kifarah and Surah Al-As. Assalamualaikum warahmatullahi wabarakatuh, and thank you everyone for joining.
Waalaikumsalam.